morning and welcome to BCS Nottingham and Derby's first event of 2022. I just want to go through some slides and a bit of etiquette for this session before we start the main event. I'll just share my screen. So tonight we've got a talk by Simon Schofield, using generative techniques to produce artworks. Simon, I believe, is also representing Nottingham Trent University. If you're not familiar with Zoom, and if you hover your mouse to the bottom half of the screen, you should find a number of controls in regards to mute, stop video, the participants, if you can see that, chat. Chat is where we prefer if you'd ask written questions, and there should be some where possibly they're about raising your hand. So that's where the controls are, which is hover in the bottom of half of your screen. Just some netiquette points. We ask you if you could please be on mute during this session, and if you can keep your video turned off. Using the question, there's no Q&A pane available, so if you can add your questions to the chat, and we'll be monitoring that during the session. Just some pointers about being aware that there's lots of people from not many different backgrounds joining this session, and they will ask questions publicly. Please be respectful and understand people's differences, and I ask you to be friendly and patient. I think above all, I'd ask you to be kind. If you can have your telephones ready for scanning some QR codes, we've got a short questionnaire which we'd like you to complete in terms of inclusion and diversity, and it also asks some other questions about how we run the branch. So if you could just scan that QR code for me, and the responses are anonymous. What I will do is also I'll put the URL into the chat so that you can copy and paste it. Send it to everyone. Okay. So all of our events are advertised on the BCS Nottingham and Derby site. Again, there's a QR code there, should you wish to scan that if you want to go straight to our website. I will also put the URL into the chat, so you can also look it up, and you'll find details of our next event in there. And I won't say there's a huge amount of content in terms of our branch page, but you'll find our aims, who's on the committee, though that will be updated because we recently had an AGM. All of our upcoming events are actually listed there, as are the past events, and many of the past events actually have videos. So if you want to look at something that's occurred in the past that's of interest, you can just go there and watch the video yourself. We do have a LinkedIn group, BCS Nottingham and Derby, if you'd like to subscribe to that. I'm one of the leaders of that to actually allow membership. Just to give you some details of our next talk, which is on the 3rd Monday in February. It's a webinar, Built-in Innovation, Why Neurodiversity is Good for Everyone. And this is by speaker Matthew Bellringer, who I believe is setting up a separate branch within, a separate special interest group to do with neurodiversity in the BCS. And again, if you want to scan the QR code, you can go straight there and you can register, and it's available for booking now. So that's our next session, and future ones will be broadcast from our email chats, and also on the website in the future. So that's all I had. Simon, let me introduce you as our speaker. Can you hear me, Simon?
Okay. Yeah, I can hear you. Yeah, I'm here.
Okay. Right. I'll stop sharing and I'll pass it all over to you.
Okay, thanks. Right. Just get the video on.
Just to let you know, you're not carrying your. No,
Oh, yeah, there I am. That's me. Okay. So am I full screen for other people now?
I can see your image, Simon.
Okay, right. Hello, everybody. Well, I'd like to start by thanking Paul and the BCS for asking me to give this talk tonight. What I'm going to talk about is some work that I've been doing over a number of years now. And it's going to be sort of two things I'm going to be showing you, really. One is a series of images which are artworks that are I'll explain and expand on. So there's actually the artwork itself, but there's also quite a sort of complicated system that I've been building up over a number of years to help generate these artworks. And I suppose the broad term that gets used with this kind of approach to artwork is generative art. Okay, so generative art is quite a broad and encompassing area, and people work with it in the visual arts, within music, within dance, within lots of different areas. And there's conferences dedicated to it. I'm a visual artist. I produce images, as you'll see. I wanted to try to avoid, if you like, getting too embroiled in sort of art rhetoric, or kind of philosophical or aesthetic discussions about the work. I wanted to focus really on the kind of ideas behind the system and the system itself and how it works. But I think it does come back to, why I want to use this system. So there is a kind of it's meeting sort of user needs, if you like. And so in a way, it's going to be a bit of a sort of functional specification, if you like, of the requirements that I want from this system. So it's going to hopefully focus on that rather than be any kind of like artistic manifesto or a broader discussion of computer art, because it's a very big field. I don't want to sort of get lost in kind of philosophical mire, if you like. So I want to keep it focused on the things that I do. Right, okay, so I want to just move on to the PowerPoint presentation. So I'm going to share my screen now. That's me. Yep, is that good? Can you see am I sharing my screen correctly now?
You are sharing a screen, Simon.
Okay, I'm going to go to full screen PowerPoint. Is that good?
That's good. Yep. Thank you.
Okay, right. Okay, so this is the title screen. Now, I suppose before we go any further, it might be worth just. I'm just trying to get rid of this panel at the side here. Oh, there we go. There we go. Right. Okay. It might be worth just discussing what is generative art. So generative, this is from Wikipedia, so it's very broad. So generative art refers to art that in whole or in part has been created with the use of an autonomous system. Now that autonomous system in certain cases can be something physical, like a machine that you built, or a chemical process, but very, very often it's computer-based these days, and of course mine is. So the autonomous system, an autonomous system in this context is generally one that is non-human and can independently determine features of an artwork that would otherwise require decisions made directly by the artist. So in some way, it's making decisions for the artist. It's kind of doing some work on behalf of the artist. In some cases, the human creator may claim that the generative system represents their own artistic ideas, and in others, that the system takes on the role of the creator. So in my case, it's not the creator, and I think there's some big issues around this, in that I'm not interested particularly in systems that claim to be the authors of the work. I'm coming up with a tool here that's helping me make the work. And I'm very much the author of the work, and I think that's a big distinction between me and some other people who are who are making systems that they're claiming are then the artist, if you like. I'm not doing that. Okay, so just a few other little contextual things. So the work that I've been focusing on, it's all about making static images, as you'll see. Okay, so these images are static. They're very high resolution, and they're aimed at print. And I mean, that in itself has sort of given rise to lots of sort of comments. A lot of people say, "Oh, but you know, why don't you, make a system that animates, your images and makes moving images?" Because obviously that's something we kind of expect with contemporary computer-based systems. But I'm really, I come from a background of fine art, and I've a love of making images, and I think it's just something I want to do. I think that the work I do is about making reasonably large scale printed images, which you put on the wall and you look at, and I think there is still a role for those in our lives, despite the fact that we can do marvelous other dynamic stuff with computers. So this is all about making still images. So I think this whole thing started. I can see there's some typos on this, but I can thinking about it about 2005, where this started as a consequence of a Nesta fellowship, and when I was asked to submit to the fellowship, I came up with this idea. I wanted to look at the idea of applying, brute computer power to making images with a massive amount of complexity in them. And I was kind of interested in the idea of, what would a million items look like in an image, and I'm just very interested in that kind of almost like an optical experience, and then see these things printed large, and what would they look like? And to my mind, it was something that hadn't really been explored very well, slightly underexplored idea, and I kind of knew I had the tools to go about doing this, because, as I say, I had this sort of fine art background from almost a previous existence, but it was building on some previous work that I've been doing. So before I engaged with this program of most recent work, I've been working on a series of projects. So this one goes back to 91, which seems like an eternity ago. And it was when I was working in the Department of Architecture at Cambridge, in something called the CAD lab there, and we were all coming up with ideas for architects, and I came up with an idea for a system which eventually got released called Piranesi, and it was about taking very sterile CAD images and then applying a kind of post-processing system to them, where you would make them into much more artistic images. This is the sort of images that architects like. So that was one thing. Now, the why it's different to say Photoshop is that what this system does, it grabs the render, but it also grabs the geometry of the render as well. So it grabs the depth buffer, and from that you can then re-infer the geometry, and you can use that to do all sorts of effects. So on the left hand side here, we've got quite a crude model, and you can see the textures being applied to it by a paintbrush, and then you can apply things like fog and things like that. So after doing my degree in fine art, I then quickly moved into working with computers and computer graphics for a particular purpose, which was to make this sort of area, expand on this area of what has now become known as non-photorealistic rendering. A lot of these ideas that were occurring in this process actually have ended up kind of translating into my more recent work for pure art images. And then after that, when Piranesi got released, I needed a bit of a breather, so I did some work with a group of musicians. I'm not a musician at all, but I was very interested in the idea of applying generative techniques to music. I'm coming up with sort of multimedia and music fusions, if you like. So this is with a group of artists called Audio Rom. We had a studio in London, and these photos at the bottom of in the ICA on the Mall, where we had some installations, and it's sort of interactive music. And I think that generative art and music is something that, you know, it is reasonably established, actually, in a way more so than perhaps in the visual world. You have quite big name people like Steve Reich and Brian Eno who do work using generative techniques with music. So that was something else I did, and I think this was then fed into more recent work. And then all the while I was doing photo montage work. So I was a very early adopter of Photoshop. In fact, I remember doing my first photo montage work using something called a Quantel paint box, which was back in the mid 80s. These are photo montage studies that are sort of landscape works that I did for an exhibition about, and they're taking sort of photographs of nuclear power stations in this case, and they're translating them into sort of what look more like classical images of ruins. So all the while interested in this. So that's a sort of background to the work that I've been doing and I want to talk about now. So the system that I wanted to explore basically was this idea about taking lots of little images and then building a very, very high resolution detailed image out of them. It sounds like a simple idea. So let's think about what's required in that system. Basically, you need to establish a very large output image. So this is something that's going to be printable at, you know, something like a very large print, you know, something that would go on a wall and be pretty impressive. So it needs quite a bit of memory in order to do that. Then you need to read in or have a lot of images that you're going to apply to that. So these are your, if you like, your input images. And then you need some sort of scripting or some sort of way of defining a set of rules where these images are then applied to the output image. And the way the systems worked really from the outset is that you've got this list of images that you either read in from file or you can generate on the fly in certain cases. And then you take one of those and then you apply a number of processes to that image. So that can be a geometric transformation like a rotation or a scale, and then it can be a sort of image processing transformation like color transformation, brightening it, darkening it, recoloring it, and then applying it to the output image using a kind of compositing technique. And the system also needs to, of course, give you real-time visual feedback so that you can see this thing being built, helps you make decisions, and you can see what you're getting. And then at the end of the day, it sort of, I guess you've got to tell it to stop, or it will stop itself, and you get to save the output image. This is a very crude kind of image of the idea. So on the right-hand side, you've got a kind of bank of what I tend to call image samples, because in a way they're rather analogous to sound samples. You know, sound samples are things that are, of course, used in sampling of music. And you would build up say a piano, you know, would be composed of a number of different samples of piano notes being played individually, and then they would be reused to create the entire sound of a piano, including full chords. And in a way, the image samples on the right hand side of this image, you know what they are little PNG files, which are in this case taken from photographs of trees, and then they're prepared in something like Photoshop, so that they've got transparent backgrounds, and therefore they're ready to be composited into the output image. So in the middle, you've got this scriptable system where you can define some process which is arbitrarily complex, if you like, to build up the output image. And on the left-hand side, you've got the output image. So I've chosen this particular image quite randomly, which is a set of trees. And if you let the system run, you end up with a kind of sparse wintry forest. But if you let it run a bit longer, you end up with a denser forest like this. And then you end up with a much denser forest. So there's something about, you know, not just, so visual feedback in the system is very important, because, you know, you know, how long the thing cooks for, if you like, is, you know, very much influences the output. So even from the very early days of these systems, it wasn't about the computer to completely having autonomy over the process. It was about kind of it doing something and you watching it and then saying, yeah, I like it now, and saving it as it was, and making sort of editorial decisions over the image. So some early results of this. So this is sort of just post the Nesta Fellowship. You know, there's a kind of forest image which has a further level of post-processing applied to it, where there's a kind of mist applied, and in this case it looks like a kind of forest, and the images have been applied top down. So the first ones that get applied are along the top of the image, and then they go down. So you get a kind of depth sorting, so that it looks like it's a natural field of trees where there are things in the foreground and things in the background, and then applying that to and then using some other sort of texture generating sort of algorithms to kind of come up with compositions. So some rather sort of Japanese looking generative images here. So there's quite a lot of authorship going on here, but there's a lot of muscle power, if you like, from the computer to generate the image. So these things would print up, I think these ones printed up about 1 meter tall each, and it forms a triptych. So reasonably large images. Oops, going back. So here's an early field. We'll look at some other fields in a little while. This is quite an early example of a field that I did using, I think, about 30 bits of ears of corn that I plucked from the side of the road in Shoreditch and photographed and then prepared, and then using a sort of texture to give a kind of wave to the texture. Here's some blossom. I think I've got here's a zoom in, and here's a zoom into the blossom. I'll go back to that image, but you can see here that I've taken the blossom flowers and photographed those and prepared them, and then created this really crazy kind of like almost like volcanic. It was like a sort of paraplastic plume of blossom flowers flowing towards you. And then you can also apply the image to drawn elements as well. So this is a very underexplored avenue that I'm keen to go back to, because I think it's quite a rich idea. But the idea that in this image there are literally, you know, hundreds of thousands of grains of sand, if you like, drawn, and little pebbles, and so zoom in, it looks a bit like this. So, you know, you can come up with really highly detailed images, and they sort of, to me, they capture something of the detail, and yet the kind of serenity of you know, like a pebble beach with the water washing over it, to get these sort of patterns that are made in the sand that are going to get washed away with the next wave. But I think the point here is that the sheer level of detail is kind of insane, and you know, artists generally don't bother, you know, making images of this level of detail. In that, you know, you'd be crazy to do so. I mean, most artists they sort of use techniques of economy, you know, where a brushstroke would suggest something, you know, and so I'm going down this opposite line, if you like, where I'm using a kind of sledgehammer approach to you know, really brutally represent all the detail that's in the image. We've got an image here of some diatoms, and they, you know, each one of those is then recolored and then pasted down to create this very sort of vibrant image. And again, that will be printed up pretty large, so you see all the detail that's in the image there. So it looks quite graphical. So this is using very simple randomness, you know, to place something down, and then randomness again to decide which one you're going to, which diatom you're going to pick, where you're going to place it, how you're going to color it. You can rotate it, you can scale it a little bit, you know. So using sort of stochastics to control randomness to generate these images. Here's one that's made out of many electronic component parts. We'll have a zoom into a little bit of it soon, but this is you know, made out of thousands of capacitors and resistors. Now here's an image which is similarly made out of lots of electronic components. You probably can't see them in this zoom out state. It looks rather like some sort of delicate Japanese kind of pen drawing almost of sort of flowers. But if you zoom in, you can see this is a zoom into that image. So you can see that the image is made out of you know these electronic components which I've carefully photographed and prepared. And then, you know, I had the opportunity to have a large installation piece in Sheffield a few years back, and so this is really pushing the scale of the images. And what I was doing here was using generative techniques to generate very intense texture. So the idea was to produce something that was the size of a billboard and yet had the detail of a magazine. You know, the magazine site type print where things are printed at roughly, you know, well, ideally 300 dots per inch, but you know, I literally couldn't achieve that with this. But something in a kind of compromise where you've got a high level of detail. So this is the zoom out here, where you see the whole thing. It's meant to be a pond. So the show was about, I suppose, art and the environment. And so I wanted to create a kind of environmental statement where it looks like a very serene, natural pond. But as you zoom in and as you look into the detail, you can start to see that at the bottom of the pond, there's all this clutter and all this sort of detritus that's been deposited down there. So we're going to have this sort of zoom now where we can see that. So we're zooming in and we get these levels of sort of chickweed and fish and other kinds of and pebbles and shells. And as you zoom in, you can see the detail, and you're just about to sort of see this level of this layer of human detritus, which is laying at the bottom of the stuff. So all these different sort of textures, they were generated using generative techniques and then kind of assembled more by hand. There was quite a complex process, which I haven't got time to go into in this particular talk, about how it was it had to be printed in panels, which had to jigsaw together in order to kind of cope with the memory size of the image. So there was something behind that, but basically there was this generative technique. So you can see here beneath the fish, beneath the weeds, amongst the pebbles, there's those cans of pop and bits of rubbish and toys and things, generally stuff that was cluttering up my life at the time, having 3 very young kids. So that was the Kettle Pond, as I call it. That was in Sheffield, and oh, there was even closer zoom, so you can see the sort of stuff that was there. And there they are. Their kids seem to like it. It's just been installed at this point. Literally stuck to the floor, and you've got the kids going on it and looking at all the detail. and finding things in there that, you know, because it supports that level of inspection. So I'm quite interested in that as well, actually, that idea that, you know, you can potentially create, you know, in fact, really large images, potentially endlessly large images, that have that level of detail that you expect to see in a kind of photographic resolution image. And that's a different phenomena to what we normally experience, because when you see something that's billboard size, generally speaking, they tend to be printed at something like 17 DPI, 17 dots per inch, you know, really, really low resolution billboards. So they didn't having a really high resolution billboard was sort of interesting to me. Okay, so let's just talk about, so more recently, been working on this idea of a, you know, how you can enhance, if you like, the process of artistic production using the generative techniques, not necessarily just using generative techniques, you know, not just pressing a button and hoping for the best and hoping that a great image pops out of that process, but sort of knowing that generally speaking, that's very rare that you can do that. It's almost never happens. So going with that idea, it's this sort of, how can you have generative techniques support the creative process rather than do it entirely? And so, you know, when you make these images, basically you start with an idea that you hold in your mind, like all artists do, and then over a period of time, you try to sort of tweak the system so that it converges on the idea that you've got in your mind. And this takes time, okay? And the system really needs to help you converge on the idea that you've got in your mind, okay? And as you can probably tell from the previous images that I've been showing you, there's a lot of randomness being used in my system. So you don't want the system to frustrate this convergence with kind of uncontrolled randomness between renders. You don't want to kind of get close in one render, make a few tweaks, and then the randomness kind of completely trash anything that you liked in the previous render. And so these human-centered requirements have led to some very specific augmentations of the system in the last few years. So of course the system does need to have this high degree of autonomy. I mean, that's something that, you know, that's what you're relying on to give you this high level of detail. The problem with that, you know, I suppose you do want to have this idea that you can press a button and you can let it run, and you can let very elaborate renders complete without intervention, if you like. But full-scale renders are very, very slow. If you think about an image like, you know, something that's the size of, say, a whiteboard, okay, in a college, that's going to be something like about 18,000 by 12,000 pixels. If you want it to be printed up at 300 DPI, excuse my use of DPI. I know that's all very imperial. I should use centimeters per inch. I think 300 DPI is 112 centimeters per inch. But it's just what printers use. Printers are very steadfastly stuck in the world of DPI, so I tend to use it too. 300 DPI, which is regarded as dots per inch, which is regarded as kind of photographic kind of resolution. So you've got this very large background image. You've also got, then you've got these things that you want to composite onto the top of it, and those can be quite large. So in the cases of the fields I'm going to show you in a minute, those bits of grass that are going to get composited to make that field, they can be really big. So they're like 10,000 by 1,000 pixels each. And each of those images is loaded in, then scaled and rotated and perhaps recolored before compositing takes place. And in a final image, you know, you might get something like 25,000 composites. And this can take a long time. It can take like half a day to do one of these renders of best quality. So obviously that's not going to give you fast feedback if you want to make rapid tweaks to the image, as you do, because most of these images start off being really unpromising. I mean, you know, when I start on an image, I've got like this idea that the first few renders just look hopeless. And so you do need to iterate around many, many times quickly. So in order to speed things up, what I've done is the system needs to be resolution independent. So what you need to be able to do is work small and fast. And then when you're happy with it, say, right, I want now to render this at full size. So coming up with a system that's resolution independent has been quite a lot of work. You've got to come up with a resolution independent architecture kind of coordinate system, and then you've got to come up with the kind of maths behind that to deal with all the scaling of the assets and how they're placed in the scene. There's also quite a lot of caching it needs to do in the background, so a bit techie to get that working, but I've got it working. And the system needs to be completely, produce completely repeatable results. Okay, so we've talked about randomness. There's no point producing the image you want at low resolution if you can't then exactly produce it at full scale. Further to that, actually, you want to be able to sort of pick out bits you like and keep them, and then change bits you don't like as well. So there's got to be those sorts of techniques at play as well. So there's a couple of techniques that I've been developing recently. One is this idea of repeatable randomness. So you've got to, the way you've got to code the system, you've got to be able to cut things up into kind of separate random streams where each random stream is very, very controllable. And the other thing you can do to help make the system, make the image repeatable over, you know, between say the small draft render that you do and then the large full scale render, is you can save certain data collections generated in one render for use in subsequent renders. So in the case of these fields, what they do is that when you do a small render, it also saves out where all those bits of grass have been planted, if you like, and what particular image they're made of, as a kind of lightweight data type that you can save as these kind of image collections. Now I call these things seeds because you then read them in and then you grow a field out of these things. So I tend to call these sort of point clouds, if you like, of data that you save off seeds for subsequent renders. I'll just check how we're doing for time. So the architecture, it's written in Java at the moment. The way it works at the moment is you've got a lot of sort of supporting classes, and it borrows from the sort of game engine idea in that, you know, a game engine is similar in the sense that games are autonomous complex systems that will run. You know, they don't just sit there doing nothing waiting for the user to do something like, say, Photoshop. There's a lot of active and dynamic activity in a game. Same with mine. So it borrows something from the game engine idea, in that you've got this abstract top-level application superclass that you need to subclass to create your user session. And the user session defines a particular render, if you like. So in that, you initialize the system, you load your assets, you define the drawing loop and all the parameters and the complex interactions that you want with all the different images. And then after a bit, it creates some sort of finishing criteria where it then saves out the image. And so then you can save these user sessions off. And you know, you might be working on several different images at the same time, so you'll have several different user sessions saved here and there. So it kind of allows a kind of kind of arbitrarily complex user session to be defined. It's a mile away from being anything like an interactive application at the moment. It really is still in the world of programming to use it, but it's kind of kept to roughly to one page of scripting that you do, or one page of coding that you do defines your particular session. Also recently, you know, there are new things that I've been bringing in. So for instance, in the case of the fields that I'll show you, there's 3D scene data brought in to support those. I can show you some maps that I've been making as well, which are nothing to do with the fields, but they're a different sort of image, but they will use a kind of graph network to help draw them. So there's lots of other data that now the system draws in from the outside to help generate images. And of course, those data sets, they're authored as well. So there's a lot more authorship going on in this, and a lot more data behind a particular image than in the previous stuff that you'll have seen. So I'm going to show you some landscapes now. We're coming roughly towards the end of the talk, coming to the most recent work that I've done. These use a proper 3D representation of scene. It comes from a special 3D viewer I've made. And then after that, I'll show you some maps, which is a sort of separate set of images that I'm working on at the moment that require a kind of node line connectivity type of graph. Again, that comes from a different application that I've written, because it's hard to extract that kind of data from Google Maps, but you can't do it basically. Anyway, so let's look at the landscapes. So this underlying 3D representation, you generate a whole set of seeds, which you're then going to grow into a field, and you use those seeds to define kind of biomes of different plant species, and they're defined statistically, and they're sorted and scaled and composited using the depth sorting that you would expect to get from a 3D scene. So this is a 3D scene that's got those points on it. So this is like where the seeds are, okay? And so using a 3D packing algorithm to put these seeds down onto the scene. And that's the kind of, if you like, the underlying structure of these things. Okay, so these, and what we're pasting onto the scene on the top is these, very high resolution matted images. So these are bits of grass, obviously, that are just picked from a field, but they're taken and photographically captured and then matted so that they're against a transparent background. And these themselves are very high resolution, because I want these images to be potentially very, very large. Okay, here's one. So here's a field, using, this is actually quite an early example. One of these ones that you just seem to get right. So underlying the image, there'll be a texture mapped image applied to the same landscape that defines the lighting, and another one that defines the waving of the grass in the so you get this idea of waves of motion and winds blowing across the grass. And so this thing could print up pretty large. It could print up sort of a couple of meters wide by a meter and a half tall at high resolution. And so zooming in, that's kind of some of the level of detail you get in this image. And then here's one with a slightly more elaborate composition, where I've used another underlying image to define the different height of bits of grass to get a kind of more of a composition going on. And you can see the edges. I mean, you can see the bottom of the image here. You've got this sort of, it seems to just end. But I quite like that, because it sort of admits how the image is made. I'm not about trying to deceive people that these are photographic images. I do want people to know that they're completely artificial. And they are, if you like, romantic whimsies, if you like. They're not meant to be photographs. They're meant to be, sort of artistic evocations of a particular idea. And so there's a zoom into that, and you can see the things in the foreground are much bigger, and things in the background. You've got the way that the whole thing is layered up, using the distance and the depth sorting that you get in the 3D image. And then this is a more recent image, which, I'm quite interested in the idea of taking, very large renders and then focusing in on a small area and saying, well, I like that bit there, and rendering that large. So again, making editorial decisions to sort of focus in. So getting quite an intimate image here, to where you're sort of focusing in on high levels of detail. And so there's another zoom into that particular image. So that's something I'm working on at the moment, and pushing the idea of these and field images and trying to get them to be more, just exploring the idea. And at the same time, another kind of landscape that I'm interested in is maps. And so this is using a network of images, and again using you've seen these guys before, but lots of electronic components. Of course, that's a map of London, isn't it? So you recognize Canary Wharf and the famous sort of loop that you see at the beginning of EastEnders. Map of London. And of course, once you've got that map, and that map's been carefully authored by me over the top of a Google map, so that I can reuse that data, those lines and nodes that create those interconnections and roads. You can then reutilize that to in many ways. So here's a re-rendering of maps, of a map, the same map, but using text as the thing you're rendering it with. So you actually get close and you can read this sort of. It's not quite finished yet, but the text is from Joseph Conrad's Heart of Darkness, for those of you who are interested, which starts in London anyway, ends in Africa. So the idea that you can take that data and re-render it. So you can see that things have moved on from the initial early experiments, and things are getting a bit more sophisticated. So wrapping things up, conclusions. Well, I think, conclusions, they're mainly the conclusions of the images, aren't they, really? I mean, I think that they are, if this is not exactly a scientific experiment following a scientific method. If there are results or conclusions, they are the images. But I think I'm drilling down into understanding, how generative techniques can be used quite productively by artists, and it's a set of tools that artists don't have at their disposal at the moment. I'm fortunate enough to be able to program so that I can make these systems myself. So I'm generating a load of emergent thoughts on generative techniques and how these are of practical use to artists, but I don't want to sort of just talk about this. But I haven't got time really to talk about it. I think that's a separate talk really, because there's lots of thoughts about how you share the work between the computer and the artist or the creator, and I suppose a corollary of that is a sort of critique, if you like, of the school of thought that says, well, we're going to make a system that makes artworks. I tend to see a lot of this in the world of music, where there was something on the BBC just this week about a system where you can, use AI to generate pop music. And, I think that's interesting, but it's not what I'm doing. I'm very much not replacing people, not replacing artists. I'm very much giving artists further tools to make different sorts of images, to have different sorts of visual expression. So that's all I'm going to say. That's the end of the talk, I think. Thank you, at the end. I'm going to come out of this, and we're going to maybe unshare now. And no, I'm not sharing anymore. Stop sharing. There we go. Right, and I'll come back into the room and have a look at the chat, see if anybody said anything. Okay. So if anybody wants to shout out, I'm going to read. I've had a brief with Paul on how we're going to do this, but it's. Do
you want me to read them, Simon, so you can just focus on answering?
Yeah, go on then. That's great. Thank you.
Okay, so first question is, are these techniques recognised as an art form outside of the IT community?
Yeah, well, actually, I mean, I have been showing the work, and it's funny actually, because from quite early on, I got a gallery in London to show my work, and they do show my work, and it's sold as well. I mean, there's quite a lot of people buying the work, but funnily enough, the gallery that initially was selling my work and showing my work was quite keen to not talk about the method of production. I think they wanted their artists to their clientele to think that I'd lovingly handcrafted, you know, all these pieces like a very elaborate and extremely time-consuming piece of craft, you know. So they weren't keen that I kind of exposed the idea that, oh yeah, you press a button and it kind of generates this thing, you know. So that was quite funny, really. But of course, it isn't easy to do these things anyway. So it is always quite a lot of work goes into these things. It's just in a sort of different area. But so yeah, I'd say that they are coming to be recognised. I think my particular techniques are just explored by me at the moment. You know, it's not something that there's a bunch of people out there exploring exactly what I'm doing. I'm sure you find work which is a little bit similar in other areas. But I think generative work tends to be a little bit niche within the art community. Still, you know, there's no one won a Turner Prize yet for doing generative work.
Sure. Okay. Thank you. Did in the 90s the magic eye craze influence your interest in generative art?
I remember the magic eye craze very well, actually, and I was really interested in it. But it didn't. I mean, I think you're right. Maybe there is a sort of nostalgia for that kind of, because they were really bizarrely detailed, and also fractals as well at the same time. You know, images of the Mandelbrot set were very popular at that time as well. And I think you're right. There was a sort of fascination with that kind of level of detail that you got in the magic eye images. People haven't seen that kind of crazy level of detail. So maybe in the subconscious sense, yes, it has, but it would be subconscious. Yeah.
Sure. Okay. Another question is an objective to ultimately produce a piece of software which is commercially available to photo digital artists,
That's
both amateur and pro?
Yeah. I'd say I would terribly mean if I said no, wouldn't it? On some sort of level, you know, no way. It's mine, all mine. I mean, I have produced commercial artwork in the commercial systems in the past and marketed them. I just don't think there'd be a big uptake, to be honest. You know, I mean, I think that's. I don't know. I think. I mean, I keep thinking about, you know, am I converging at all on an interactive system here? And I don't think I am at the moment. So it's still very codey. You know, it's not user friendly. The things are defined by like a page of code, basically, and so it's a way off being anything that I think anyone would want to use really at the moment.
We've had another question, which is excellent work. My question is about the ownership of this kind of art.
Ownership, yes. Well, I'm very much the author, if that's what you mean, in terms of, you know, because there is some art, you know, some artwork always comes out. I mean, like AI-based art and things like that, you know, and again, music, it seems to come out that, you know, where people are saying, I've made a system that can produce music like Bach, or, you know, can write pop music, or can produce classical paintings. And, you know, I still think even in those situations, even though those people might say, and it's completely independent, you know, of any human interaction, I think that's not really true, because in order to get to that position of having made the system, you've labored for months and years, maybe, coming up with a high degree of authorship that has created that system. And then that system is simply just doing what you've asked it to do. So the idea that you're divorcing yourself from the act of authorship, I think, is disingenuous, really. So I very much embrace the idea that I own the artwork, you know. Yeah.
We've got a question. As a matter of curiosity, do you use processing like this in your university modules? I guess is what they're asking. So
Yeah,
do you use this as part of your teaching?
Well, so just processing as in the general term processing rather than the language. It informs my work. I mean, I teach a graphics module that does a lot of image processing. So yes, that definitely has informed me. But I mean, obviously, you know, students need to get to grips with how to do image processing and know how to manipulate images. And so yeah, it informs my teaching a lot. Yeah.
Okay. What are your thoughts on NFTs and art?
Yeah, I don't know. I'm completely confused by them, to be honest. I don't get them. I mean, I sort of do get the idea. I mean, I got them. I sort of got it more when the National Gallery just released a bunch of NFTs against some Turner paintings, didn't it? I didn't get it at first when Beeple, this American artist, made 57 million out of selling an NFT for his work, because I didn't even know who Beeple was, right? I didn't get it. It struck me as a kind of title deed to some rubbish piece of artwork, really. Now, Turner's not rubbish, okay? Turner's really good and famous. And the idea that you can buy this NFT and it's kind of against this value, it strikes me that it's trying to recreate what money used to be. You know, that money used to be against a standard, like the gold standard or the silver standard. And so you have it against something like a Turner. Is that what it is? I don't get it, really. I mean, if anyone could help me here.
I can't.
It's something to do with value and uniqueness. And I don't know. It's very philosophical, isn't it?
Sure. Why did you turn to computing to express your art?
Good question. Because I did that. I wasn't into it at first. When I was at art college, I was painting, really. I think that I've always been torn between interesting creativity and painting and making art and making music and things like that. And I loved computers from the outset. I mean, I remember being in the sixth form and just the first Apple II came out and we had one in, you know, it's just, you know, if you're lucky, you get on it, you know, to play around. I just loved computers and immediately saw computers being really interesting and creative. And I just always had that sort of passionate engagement with computers, really, just in that way. How, you know, what can we do with this that's really interesting and creative? And I think it just carried on, really, you know. So it's just a sort of an odd set of interests, really, you know, really that just lives in me. But I'm not unique in that way. I mean, there are other people who are interested in the two, but yeah, I'm fascinated in computers, fascinated in creativity. And I think the overlap's really, really interesting.
And the last question, do you foresee any practical, industrial or enterprise applications for your work?
Yeah, I mean, I think there are. I think there's, you know, like bespoke wallpaper, you know, where there's non-repeating wallpaper is an interesting idea. If you think about, you know, design that doesn't repeat, but you can have a whole room full of it. That's a really interesting idea. It's not been explored. You know, wallpaper's the same as it now as it was in William Morris's day, you know, when the first wallpapers were sort of generated. So, but the idea that you can create non-repeating wallpaper and textures and, you know, massive non-repeating images that are very high level in detail, but, you know, could be the size of a football field. I think there are commercial applications for that. And I think it's down to other people to kind of identify them, really. And I'm very happy to work with these people, whoever they are.
Okay, thanks, Simon. That's all the questions.
Okay, thank you all very much for your fantastic and very good questions. Right, thank you very much.
Okay, well, Simon, thank you. That was absolutely fascinating talk. I really enjoyed it. So we've reached the end of the session. Thank you for joining. If you want to check our website, as I mentioned at the beginning, if you want to look at our forthcoming events, please do so, and you can register there. Other than that, I bid you all a good evening. Happy New Year. and hope to see you in February. I think it's the 21st. So I'll stop recording now. And thank you very much for joining.